All right, here we got the notes for section 2.7, solving equations in one variable. So the first type we're going to solve is rational equations. So rational equations involve rational expressions or fractions. Every rational equation can be written in this form. So from some function of x divided by some other function of x is equal to 0. If f of x and g of x are polynomials, then the zeros are the solutions. When you multiply or divide an equation by an expression containing variables, the resulting equation may have solutions that are, not solutions of the original equation. These are extraneous for the reason we must check each solution in the resulting equation. So here's we go. The easiest way to handle these is to multiply by the common denominator, or at least a common denominator. So in this case, there's only one denominator, so I'm going to multiply everybody by x. So what's going to happen is x squared, 3 over x times x. So I'm going to actually write the intermediate step. Looks like this, because this x is x over 1, so it only multiplies the numerator. Now those x's are going to cancel, so if you saw that right away, that's fine. So you would have this equation. This is a quadratic, so everybody comes to one side. And then I set equal to 0 and solve. So let's see, this is factorable. So we have x minus 3, x minus 1. So the solutions are x equals 3 and x equals 1. But I have to check and make sure that those work. So if x is 3, my equation becomes 3 plus 3 over 3 equals 4. So this is x equals 3, which is 3 plus 1 equals 4, 4 equals 4. So that solution is good. I have to check x equals 1, which becomes 1 plus 3 over 1 equals 4. So 1 plus 3 equals 4, 4 equals 4. So this one is also valid. So both solutions in this case worked. That will not necessarily always be the case. So for example 2, there's only one denominator, so everybody gets multiplied by x minus 4. So x times x minus 4. So I'm going to skip the intermediate step because this x minus 4 is going to cancel that x minus 4, leaving me just 1, the numerator, and 0 times anything is 0. So do your FOIL, x squared minus 4x plus 1 is equal to 0. So this guy, though, is not factorable, so we have to quadratic it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is 4 plus or minus the square root of 12 over 2. So that is 4 plus or minus 2 root 3 over 2, which is 2 plus or minus root 3 is my solution. Then I need to check my answers because of course we do, because we always check our answers if we have a rational function, because that's what you do. So let's see here. So let's try it. So we'll have 2 plus root 3 plus 1 over 2 plus root 3 minus 4, and see if that equals 0. So this is x equals 2 plus root 3. We'll also need to check x equals 2 minus root 3. So 2 minus root 3 plus 1 over 2 minus root 3 minus 4 equals 0. So, and that'll just fun go in your calculator, and you will get actually true statements. So these solutions are both valid again. Okay, extraneous solutions. So here's the hint. All right, solve the equation. So this, so your first step, if you see a quadratic in the denominator of one of your rationals, you should try to factor it. Using your common sense, it should probably factor as the other two over here. But just in case, we'll make sure. So we need to multiply to 3 and add to negative 4. So it has to be negative 1, has to be negative 3. So eliminate the fraction comes next. So the common denominator for this is actually x minus 1 times x minus 3. This one has an x minus 1. This one has an x minus 3. This one has both of them. So in order to cancel both of them out, I need to multiply by both of them. So when I take my quantities times the first fraction, x minus 1 cancels x minus 1, which just leaves me 2x on the numerator and the x minus 3. For the middle term, the x minus 3 is going to cancel the x minus 3, leaving me the 1 from the numerator and the x minus 1 that didn't get canceled. On the right-hand side, both quantities cancel. These are both in the bottom here, leaving me just the numerator. The numerator should always appear. So do some distributing. So that's 2x squared minus 6x plus x minus 1 is equal to 2. So since I have a quadratic, everybody comes to one side. So doing some like terms, that's going to be negative 3 equals 0. So I'm not sure that's factorable. Probably is. We'll try it. Well, to get 2x squared, it has to be 2x and 2x. It's going to be minus 3 and plus 1. So the solutions are negative 1/2, if you solve that one, or positive 3. But I need to check my solutions. So if I plug negative 1/2 in, I need to make sure all of this works. So give myself enough room here. So when x is negative 1/2, you get 2 times negative 1/2 over negative 1/2 minus 1 plus 1 over negative 1/2 minus 3 equals 2 over negative 1/2 squared, 4 times negative 1/2 plus 3. So let's work out what this is. So the first fraction, 2 times negative 1/2, that's negative 1. So that's negative 1 divided by negative 3/2. So this one is 2/3. This is going to be minus, so 1 divided by the quantity negative 1/2 minus 3. That's negative 2/7. And over here I have 2 on top, and on bottom 1/2 squared plus 2 plus 3 is 5 1/4. So 2/3 minus 2/7 is 8/21. 2 divided by 5 1/4. Whoops. 2 divided by 5.25 is 8/21. So negative 1/2 works. So let's try the 3. So 2 times 3 over 3 minus 1 plus 1 over 3 minus 3 equals 2 over 3 squared minus 4 times 3 plus 3. Now right away, we should hopefully see a problem. So that's 6/2 plus 1 over 0 equals 2 over 9 minus 12 plus 3. So, which is also 0. I cannot divide by 0. So this is 3 plus 1 over 0 equals 2 over 0. This doesn't make sense mathematically. X equals 3 cannot be a solution. All right, so example 4. So let's see here what we've got. So let's factor that third one. So that's that. That's that. That's going to be x and x plus 1 equals 0. Oh, there's a typo. That should be a 2x, so that should be a 2. Okay, so just like before, the common denominator is the x and the x plus 2. So times x, x plus 2. So for the first fraction, the numerator stays. That x cancels that x, leaving me x plus 2. For the middle term, the numerator stays. The x plus 2's cancel, leaving me just multiplied by x. And for the third term, both of them cancel, which leaves me just the 6. So this would FOIL, so that's x squared plus 2x minus 3x minus 6 plus 3x plus 6 equals 0. So like terms, I've got x squared plus a 2x because that cancels that, and that's it. So everybody else is gone. So common factor, take the x out. It is technically a quadratic. If you want to use the quadratic formula on it, you could. So set the factors separately equal to 0. Gives me this. So there's one solution, and here is the other solution. But I need to make sure that they work. So if I plug 0 in, So if x is equal to 0, I get 0 minus 3 over 0, and I'm done right away. This one can't work because it's forced me to divide by 0. It does not matter what the rest of the problem is. I can't finish it because as soon as you try to divide by 0, it's going to break down. So that one doesn't work. Let's try -2. So if x is -2, that becomes -2 minus 3 over -2. So that one's going to be okay. Plus 3 over -2 plus 2, and there's my problem. That's going to be 0. -2 doesn't work either. This equation has no solutions. Nothing works. All right, example 5. So how much pure acid must be added to 50 mils of a 35% solution to produce a mixture that is 75% acid? So we're actually going to work in terms of acid. So if we have 35% solution of 50%, so let's find 35% of 50 mils of my solution, so 0.35 times 50. So there are actually 17.5 mils of acid in my solution, and I want to end up at 75% acid. And if I'm adding pure acid, here's how the math works. So I have 17.5%, I have 17.5 mils of acid. I'm going to add some more. On bottom, I have 50 mils currently, and since I'm adding pure acid, whatever volume of acid I add is also goes into the total volume, and this needs to equal 0.75 or 3/4 because I want it to be 75% acid. So get rid of the fraction, so multiply both sides by 50 plus x, so 17.5 plus x equals, because the 50 plus x cancels that 50 plus x, so 0.75 times 50, that's 37.5 plus 0.75x. So I'll bring our x's this way, so 0.25x, 1x minus 3/4x, and take that way is 20. Divide everybody by 0.25, or 1/4 is 80. So x, I need to add 80 mils of pure acid if I want to end up with a solution that is 75% acid. I'll end up with 130 mils total, but it doesn't matter about that. So example 6, a rectangle with minimum perimeter needed of its area is 200 square meters. So let's see here. So I know that the area is length times width is 200. I know that the perimeter of a rectangle is 2 lengths plus 2 widths. And this is the equation I want to make as small as possible. The problem is I have too many variables. So I need to solve this equation for one of my variables. We'll just solve it for L. So L is equal to 200 over the width. And I can take this L in for that. So the perimeter is 2 times 200 over W plus 2W, which is 400 over W plus 2W. And if I want to find the minimum value, essentially I need to look at the graph. And my calculator will actually find a minimum value for you. So menu, graph, so 400, we're going to use X instead of W because it doesn't actually matter. Draw, zoom, auto. So there's my shape. G-solve, oops, we want a minimum value. Did I type that in wrong? 400 over X plus 2 over X, right? So I'm going to graph that equation. Let's see, what is the problem? It should be over here somewhere. Because I didn't go far enough over. That's the problem. Let's try G-solve minimum. There it is. So the minimum value is a width of 14.14. What it wants to know? Find this least perimeter. So the length then if length is 200 divided by W, so 200 divided by 14.14, 14.14, so the perimeter is that number times 4, so the perimeter is 56.58, and this is kind of a trick question, because if you want to find minimum perimeter for a given area, it's always a square. So I just need to figure out what's, so take the square root of 200 and you'll get 14.4 for one of the sides. Okay, Stewart Cannery packages tomato juice into 2-liter cylindrical cans. Just as a note, 2 liters is 2,000 cubic centimeters. 1 liter is 1,000. So find the radius and height of the cans. If the cans have a surface area of 1,000 square centimeters. So here's what we know. The volume of a cylinder is pi r squared h. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. So if the cans have a surface, so the volume has to be 2,000. So this statement must be true. And this statement has to be true. So I have 2 equations, I have 2 variables. So what I can do is I can solve one of the equations for one of the variables. The volume one's gonna be easier to solve for. I'm gonna solve it for h. So 2,000 over pi r squared, and then plug it in over here. So this equation becomes 1,000 equals 2 pi r squared plus 2 pi r, and instead of h, I'm going to have 2,000 for pi r squared. So 1,000 equals 2 pi r squared. So that becomes plus, so the pi's cancel, leaving me 4,000 in the numerator, 2 times 2,000, and on the bottom, r here cancels one of the r's over r. So this is the equation that I need to solve. So the easiest, honestly, way to do this is once again with a lovely graph. So let's try it out here. So let's see here, menu, graph. If you have, you can do this one of 2 ways. You can set one side equal to the other. I'm going to use, your calculator's expecting x, so x instead of r for this case, plus 4,000 over x. Draw. So you can kind of actually see it already from my previous zoom. So there's actually 2 locations where it works. So I'm looking for the intersection here. So there's one r value of 4.62, and there's the other r value of 9.65. So there are 2 possible radiuses. So to find the heights that go with them, I'm just going to plug them back into this equation. So with this radius, will give me some given height. So let's see here. So 2,000 divided by pi times 4.62 squared is 29.83, and if it's 9.65 for the radius, it's 6.84. So I can have a narrow can that's relatively tall or a wide can that's relatively short, which makes sense. Depends on where you want to put your volume and whatnot. All right, and that brings us to the end of the section.